In this video, we're going to talk about the basics of scientific notation. Let's talk about the different parts of a scientific notation number. Now, scientific notation is used to write really large or really small numbers. We have the factor, we have the base, which is always times 10, and the exponent, which tells us how far to move the decimal point. Please remember that the base will always be times 10. The factor is the heart of the number. It's the most important piece. And you'll see those same digits in the expanded form, although the decimal point will likely have moved. There are many things to remember about the factor. First, the first digit is always a single non-zero digit and is negative if the number is negative. And then immediately following the first digit, we have a decimal point. And then the rest of the digits come after the decimal point. The exponent tells us how big or small a number is. Positive exponents move the decimal point to the right and represent very large numbers, and negative exponents move the decimal point to the left and represent very small numbers. To convert a number from scientific notation to standard form, first move the decimal point the same number of places as the exponent. Move the decimal point to the right for positive exponents to get you a large number, and move the decimal point to the left for negative exponents to give you a very small number. And if it's 0, don't move the decimal point at all. Let's practice this with a very small number. You can tell it's a small number because the exponent is negative. It tells us to move the decimal point 5 places to the left. So we're going to put the decimal point right there, 5 places to the left. And then we're going to fill in the gaps with zeros, and then finally rewrite that number with the leading 0 and get our final answer. Here's an example of a large number. Notice it's going to be a large negative number, and we move the decimal point 4 places to the right. Now I'm just writing right over the number, but you could rewrite it if it was a little clearer for you. And so we move it 1, 2, 3, 4 places to the right, appending zeros as needed, and then we put the decimal point at the new location and have our new number. Don't forget that we need to get rid of the exponent and the times 10 base. To convert a number from standard form to scientific notation, we're going to move the decimal point so it's just after the first non-zero digit. Then we're going to write the remaining digits down. Finally, write a times 10, and the exponent is how far the decimal point moved, and the sign of the exponent is positive for large numbers and negative for small ones. Here we have a very small number, and the first non-zero digit is 5. So we write 5.783, and then we see how far the decimal point has to move to get to be just right after the 5. So we count 1 space, 2 spaces, and then 3 spaces, 4 spaces, 5 spaces, and 6 places. So it had to move 6 places. Now it's a very small number, so it's going to be a negative 6. Here's another example with a really large number. Notice the decimal point starts hidden at the very end. And so we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 hops to get it to be just after the first non-zero digit. So we're going to write negative 6.97 times 10, and then we know that it took us 13 hops, so we're going to write the number 13, and we know that it's a positive 13 because that's a really large number. In comparing two numbers, we want to look at the exponents. If I look at these two numbers, 5.12 times 10 to the 12th versus 4.98 times 10 to the 15th, the difference in 5.12 and 4.98 is not very much. And even if it was 9 and 3 or 9 and 2, the differences wouldn't be that much compared to the exponents. So really, we're comparing 10 to the 12th and 10 to the 15th. And 10 to the 15th really is 10 to the third times bigger than 10 to the 12th. That's 1,000 times bigger. So make sure you're paying attention to the exponents when you're comparing these numbers in scientific notation.